Okay, well, we'll go ahead and get started to get us started on this Friday afternoon and then get us to the weekend for some of us. But welcome everybody to the start of our graduate school virtual Q&A series. For those of you who I haven't met yet, my name is Marissa Miller, and I serve as one of the career counselors within career development and corporate relations within engineering. And I'm just really excited to not only see some of I don't get to see too many faces right now, but just see some of your names here on the series, and cannot wait to welcome Dr. Fergus to each of you as we get going today. So a couple things that will be happening today as we go through the session. If you have questions or want to kind of ask Dr. Fergus something as he goes through his presentation, I ask that if you just want to chat me through the chat mechanism with Zoom, that way I can help moderate so that Dr. Fergus has enough time to get through all of his material. If you have questions about Zoom, or if something's funny, if you can't hear us or any technical questions, I will pretend that I am a Zoom expert. So if you want to chat me that as well, I'm happy to help. We are recording today's session, and so as we go through today, I will happily follow up with each of you after the session to provide the recording so you can go back through some of the material that our guests will be going through. And also near the end, I want to make sure to encourage each of you to stay on. I will be sharing with you what our series will look like at the start of next week. And so we will be going through an overview today of graduate programs should you be interested in pursuing graduate school here within the Samuel Ginn College of Engineering. And then starting next week, we have invited some of the graduate program officers to speak about their individualized programs and some of the resources and opportunities that are available as well. So without further ado, I am going to hand this over to our guest today. Please help me in welcoming Dr. Fergus, and I will hand it over. So thank you all so much for being here. If you can all stay on mute, that would be most helpful so that Dr. Fergus has all of your attention, and then just please chat me with questions. So Dr. Fergus, thank you so much for being here today.
Okay, thank you. So can there we go. Let me find the right window. Sorry about that.
That's okay.
It was the one off the screen. Can you see it now?
Yes, looks great.
Okay, good. Okay, so what I was going to do was to start off just talking generally about graduate programs and then go into our specific programs. And as Marissa mentioned, next week you can have the opportunity to talk to those graduate program officers about those programs. So first of all, why would you want to go to graduate school? And of course, typically it's to provide yourself with more opportunities, different types of jobs. But what do you get out of graduate school that does that? So there's a few different aspects. One is you could go into more depth in your particular area. So an advanced degree if you're in mechanical engineering, another degree in mechanical or electrical or whatever it might be, to get in a lot more detail in specific areas, more rigorous approaches. But there's also opportunities to expand your background. So in some degree programs, you can enter those with a different undergraduate degree. And so, for example, in my own discipline, materials engineering, we often have graduate students who come from other disciplines. Either they come from another engineering discipline because they want to learn about materials and enhance that degree, or they come from chemistry and physics because they want to kind of get more applied. And the same is true in other types of disciplines. So different disciplines allow that more than others, but sometimes it allows you to have a broader range of experiences when you're looking for a job or other opportunities. The other thing that's different about at least some graduate programs, so some graduate programs are courses where you just take more courses, more advanced courses, but then others include research in them, and some of you may have done research as an undergraduate. Graduate programs, depending on the program, have more and more research, particularly a PhD. And that's a different kind of experience. So when you think of going to graduate school, you've gone to undergraduate for 4 or 5 years, and oh, I don't want to go for another however many years. Particularly if you're going for more than just a master's or PhD, the experience is very different once you get into doing research. You do take some classes, but then after you get through your classes, you're basically working on research. It's more like an employment as opposed to study. You are still learning, but it's in the laboratory or on the computer that you're doing new research. And it's a different way of learning. And of course, you continue that learning throughout your career, but you're kind of learning how to do research so that you can continue in that field if that's in your area of interest. So along those lines, there's some different types of graduate programs. We do have what are called certificates, graduate certificates, and these are smaller than a degree. So they're typically 9 to 15 credit hours, so 3 to 5 courses. I think most of the ones in engineering are 4 or 5 courses. And so it allows you to focus on a particular area, get some credential in that area. It's not a full degree. They can be combined, so you can take multiple certificates and use those courses also for a degree, which is a little bit different from an undergraduate. Like you take a minor, the minor is on top of your undergraduate degree, so you can't double count the classes. For certificates, you can double count all those classes. So you can take 2 or 3 certificates, and then once you have enough courses, if those apply and satisfy the requirements for a master's degree, you can get a master's degree. So it's a way to get a smaller credential, and if you're interested, you could just take that if that's all you need, or if you want to pursue more education, you can build on that to get a master's degree. So kind of the next level would be a master's degree. And there's 2 different types, or typically about 30 credit hours. And there's either thesis or non-thesis. So the non-thesis is essentially courses. Sometimes there might be a project course, but basically it's courses, so about 10 courses. And so that's probably the most similar to your undergraduate degree. It would just be, you would be taking courses, they'd just be more advanced courses than typical undergraduate courses. Then there's also Thesis Masters, where you typically will get about 6 hours of credit. You can get 4 to 6 hours of credit for your research. So you take fewer courses, but then you have to do research. That typically leads to it taking longer because you're doing research, but as I'll get to in a minute, there's also more likely to get financial support for that because you can get paid to do that research. Because you can take 30 credit hours in a year, right, in an undergraduate. Now, typically graduate students don't take quite as many courses. The official full-time for undergraduate is 12 credit hours. The official full-time for graduate students is 9 credit hours. So usually you take a little bit less, but you could still finish 30 credit hours in a year, particularly if you go the summer, if you're just taking courses. If you're doing research, it generally takes a little bit longer to do that research. So with a thesis, it typically takes a couple of years to complete a master's with a thesis. But again, as I'll mention, then there's more opportunities for actually being paid to do that research than to fund your education. Then the next degree is a PhD, Doctoral Philosophy. And that's typically about 60 credit hours, so about twice that of a master's. And you can use the master's courses for the PhD. So it's not twice as many courses. It's typically some more courses, but not, depending on the degree program, certainly not 60. And in some disciplines, this varies somewhat between disciplines, you can go directly from a bachelor's to a PhD. In some cases, they like you to get a master's first and then a PhD. More and more are going towards allowing direct from a bachelor's to a PhD if you're so inclined. So it can take, if you go directly from a bachelor's, it's probably about 4 or 5 years to complete a PhD. And you say, well, 4 or 5 years of school, again, the nature of that is very different. First year, you're still taking courses. After a year or two, you might take a course here or there, but for most of the time, you're spent doing research in the laboratory or in a computer or whatever it might be for the type of research. So it's not another 4 years of courses. It's some years of courses, but then a research experience. So it all depends on whether that research is what you're interested in, and you're interested in a career in research. If you do want a career in research, then you pretty much need a PhD. But of course, if you another career path, you don't need it. So it depends on all what you want to do. So these are the different types of degrees, at least in engineering. Obviously, there's other types of degrees like MBAs in business or law, other types of degree programs, but I'm focusing here on engineering degree programs. So as I alluded to, obviously you're interested in how you're going to pay for this. So I've divided into two. Many of our students are working part-time. So if you do, even if you do get a full-time job, you still could pursue a graduate program part-time, and particularly online. So most of our courses are offered online. Even before this semester, we've been doing this actually since before I came to Auburn in '92. I think it's from the mid-'80s. At that time, it wasn't online because there wasn't really online. It was a VHS, and probably many of you have not even used a VHS, but a videotape. And so they would record the lectures and mail the tapes out to students who are working, and they would do the work and mail back in. Obviously now it's online. So these students are working full-time, and then the lectures are recorded and they come in the evening or weekend and watch the lectures, do the work, send it in. Often in that case, many companies will reimburse either all or some of that. So that's a way to finance the education. Typically, if you do that, we would recommend you start off with maybe one course. But once you kind of figure out how to do that, taking a couple of courses, so most students can do that. So it's going to take. Is there a question? So since you're only taking one or two courses, it's going to take longer to complete, but obviously you're working full time. So the other way is to go full time. So just basically go to school. And in that case, if you have enough money, obviously you can pay for it. But if you need financial assistance, there are what are called graduate assistants, and you've probably had GTAs in some of your classes. Those GTAs are pursuing a graduate degree, and then they're also have some teaching responsibilities, and for that they're paid a stipend. In addition, if the commitment is above a certain level, they get a tuition fellowship. So you're being paid and your tuition is being paid. So basically you're working. But obviously you have more responsibilities than just taking classes in that case. So there are teaching assistantships where the responsibilities are teaching, might be grading for a class, might be running a laboratory, in some cases maybe even teaching the class. And then there are also research assistantships where you're working on a research project. So the funds from that will come from a funded research project that a faculty member has. Most of that research is done by graduate students. So the graduate students are paid a monthly stipend, and then at the same time take their classes and work through their degree. Some students will have a combination, so they might have a research assignment and a teaching assignment. And so they have both going on. Because if it's a research degree, you need to do the research anyway. And fortunately in engineering, the research you're being paid for is the same research that you can use for your degree program. In some disciplines, students will get money for research, but it's separate from what they're doing for their dissertation, and then it can take a long time. But in engineering, generally, you can be being paid for the research that you're doing, which then is also what you use for your thesis or dissertation. Usually the term thesis is used for a master's and dissertation is used for a PhD. So that's kind of the base assistantship. Then there are also opportunities for fellowships. A couple different kinds. There are external fellowships, and these are things like the National Science Foundation has graduate research fellowships, which you can apply for as a senior or in your first year or two of graduate studies. These are very competitive. So you can apply, and many don't get them, but it's worth applying. And if you get those, then basically you can go and you're paid for, so a faculty member doesn't have to pay his or her research funds to pay you. The stipends are quite good, and they're quite prestigious. So when you go to look for a job, the fact that you earn that is a good thing. We also have some other type of fellowships which are essentially supplements to the assistantship, so just to raise the level of the stipend. We have some in the College of Engineering, and we have those due to the generosity of some of our alumni. Walt Waltos and Charles Gavin in particular have funded these fellowships, which allow us to increase stipends to try to make them more competitive. There's also university as a program, presidential fellowships, which the college contributes to and the president contributes to. So the amounts of those range from $24,000 to $32,000 or sometimes even more per year for the assistantship plus the fellowship. And again, that's also, in addition, you have tuition paid for. Those, and it depends on when you're looking for, those decisions have pretty much been made for fall. The normal cycle for fall is the applications are typically due early in the winter, and then or offers are made in the spring and accepted by April is the normal time frame. There may be some adjustments, obviously, because of COVID-19. There's people who aren't coming and things like that. So there may be some opportunities there normally wouldn't be for fall. But that's kind of the typical schedule for the general cycle for graduate programs. So those are the different types of funding opportunities that are available. In terms of the specific degree programs we have, there's a couple different types of master's degrees. The first type, these are all the same disciplines that we have or used to have undergraduate programs in. So they're just more advanced in all those same disciplines. And again, you can certainly go to an advanced master's degree in your own discipline. In some cases, you can go to another discipline if you want to expand your background to cover more areas and make yourself more marketable. Then we have a few other types of master's degree, which are either in special areas or just a different target. A couple in the kind of computing area, we have the cybersecurity engineering. That's a relatively new, it was established, I think, 1 year ago. And then there's also, which is obviously a very important topic now, data science and engineering, which is joint with the College of Science and Mathematics. So you can have data science or engineering focus or a science mathematics focus. That one's new, just started this year. Then there's a Master of Engineering Management. So this is for those, if you're in engineering and you're kind of working your way up into management, to learn the kinds of things you need to manage in a technical environment of manufacturing. There's some different focus areas you can choose within that area. That's been about 2 years ago. And then the last one here is called Master of Engineering. And this is an interdisciplinary program. It's meant for someone who, the primary target is practicing engineers, but it's not limited to them. But if you're, say, a mechanical engineer working in a plant, you realize, oh, I need some kind of manufacturing quality control. Maybe I need to take some industrial engineering courses, or maybe I need a couple mechanical engineering courses and some Six Sigma, or maybe I need some materials because I'm worried about the materials we're using for whatever product we're using or producing. So you can develop a plan of study that meets your particular needs. And that may be a combination of some different disciplines. So it's a very flexible degree that the student has to define, well, what am I trying to get out of this degree? How is it to thinking about what's going to help you advance in your career, and what combinations of courses will help. And so you can put that together. Now this one's particularly amenable to stacking to use with certificates. So if you put a few certificates together, that basically will, in all likelihood, satisfy the Master of Engineering degree program. And so you might get a certificate and decide a little bit later, well, maybe I get another certificate. Well, now I've got, say, 8 courses. If I take a couple more courses, I can put those together and get a degree. So that's something to, those work well together, the certificates and the Master of Engineering degree program. And I should have mentioned these other, all of these, I said these as masters, there's PhD degrees in all these other same disciplines as well. So if you're going to a research career and you need a PhD, that would be, those are also discipline specific. I mentioned the certificates earlier. These are the certificates that we have. So automotive, cybersecurity engineering, the data analytics, occupational safety and ergonomics. This one's in the automotive been around for a long time. The occupational safety and ergonomics is probably the most highly subscribed. The others have come in the last few years. Power engineering, that's in electrical engineering, pulp and paper, tribology. Civil engineering, these have just been submitted. I think they're going before the board in the next few months. So those will be available. There's actually, I haven't listed them all because there's in pavement structures and water resource, each of those there's 2 different options. So again, you can stack those together to, if both of the certificates were saying civil engineering, you could probably get a Master of Civil Engineering degree. If maybe you have one in civil and one over in cybersecurity or power, then those might stack together to make the Master of Engineering degree. So how do you apply? All the applications go through the graduate school. Go to the graduate school website. There'll be a place that says click here to apply. The system's called Apply Yourself, where you go in and enter your information. You may have seen that Dr. Flowers sent out a message that for Auburn students, if they apply to graduate school, the application fee will be waived. So there's no cost, at least in terms of financial costs, to applying. I mentioned that there's you can take up to 12 courses as a non-degree student. That might be just because you only have 1 or 2 courses you're interested in. It also could be if, for example, I mentioned the civil engineering programs are being approved. If they're not quite approved, but they haven't gone to the final approval, but we know what they are, you can start taking the classes even before the degree or the certificate is finally approved as a non-degree student. So that's an option to take a few courses. As I mentioned, the finances, particularly for full-time, primarily are related to these assistantships. And so to get those, the best thing to do is to find, in most departments, those are primarily determined by the faculty members, because the faculty members have the research projects and they are looking for graduate students to work on those projects. So finding a faculty member who's doing research that's of interest to you and talking to them and see if they have need for a student. And this is where there may be some, even though I mentioned the cycle for fall, if say you've decided, oh, maybe you'll think about fall going to graduate school when you hadn't before, you kind of missed the normal cycle. But there are always new projects that come up. I think there's been a few announced in the last week or so. So if a faculty member gets a new project and hadn't been expecting that or hadn't counted on it, and all of a sudden they hadn't recruited a student and now they need a student, there might be an opportunity there. Or there may be some students who decided because of COVID-19 they won't be able to come or don't want to come for some reason. That might open up a possibility. So if you're thinking of fall, even though normally it would be kind of late to do this, there might be some opportunities, so it's worth looking into it. The normal cycle would be to, again, as I mentioned, starting to apply in late winter, December, and applications are typically due January, February for the following fall. But like I say, there may be some opportunities this year because of this particular situation. And even for the fellowships, that's still a first good step, because for at least the college fellowships, you need to have the assistantship to get the fellowship. And even if you want to apply for an SF fellowship, for example, if you find a faculty member who's doing some research, you have to write a proposal for that. You might be able to write your proposal that aligns with a professor who's doing something you're interested in. And maybe you don't get the fellowship the first time, but you can maybe work with them as an assistantship and then try again and get it the second time. So it's still worth, if you're thinking about a research career, to talk to faculty members who are doing research that looks like it's of interest and seeing what those opportunities might be. And I think that was all I had for slides. So
That's fantastic.
Leave plenty of time for questions, but that just kind of gives you a general overview of what kind of graduate programs are available and what we have here.
Wonderful. Thank you so much, Dr. Fergus. That was fantastic. We have had several questions come in while you were speaking, and so I might jump to a few that were most in relation to what you just covered in terms of the application process, and also some considerations in relation to considering graduate school overall. So one of the questions is in relation to, for students that may be already infused into research, so at the undergraduate level, does that typically, is there a correlation there that may help kind of the likelihood of gaining additional scholarship or funding at the graduate level? Has that been an opportunity in the past that you've seen with student applicants?
Certainly, when a faculty member is looking for a student, if that student has some research experience, that's going to be a positive. I've in the past evaluated the NSF fellowships, and those are, like I say, very competitive. And I would say any of them that were successful would probably have had some research experience. So yes, the research experience is helpful. It's not necessary. I mean, you can still get a graduate assistantship if you haven't had undergraduate research, but it is going to help you to have that. And even with that, of course, if you want to stay at the work with the same faculty member, that also helps. But even for a different faculty member, just that you have some experience, particularly if you have some presentations or publications that you're part of, that helps too. So yes, it will help.
Wonderful.
Primarily for the assistantship. Probably, and there's really kind of two levels. One is being accepted into a program. That's mainly judged that you have the background that you'll be successful in taking the classes and completing the program. And then if someone's going to support you with an assistantship, that's when they're looking for, are you going to be good in a lab? And they're not always exactly the same. So that's where showing that you have some experience and that you can talk about it. So if you contact the faculty member and can talk about what you did and show how, your enthusiasm about that and your understanding of what you did, that's going to go a long way.
Wonderful. Thank you. Transitioning just a little bit, earlier when you spoke about the differences between certificates, the master's, both non-thesis and thesis, as well as the PhD, if a student were to initially kind of identify that they are most interested at the master's level, is there at all an opportunity in starting the master's program to transition to the PhD program, or must they complete the master's before being reconsidered?
Oh, yeah, either works. And it really depends on the particular situation. For example, I don't have a master's degree. I only have a bachelor's and a PhD. And in my field, that's very common. And I think it's becoming more common in more disciplines. But if you start on the master's and if you've just taken a few courses and decided for the PhD, you probably would just switch over.
Okay.
If you're kind of close to finishing, and particularly if you're going to change projects, you might, because really the only difference is writing up a master's thesis and a PhD versus just a master's thesis. You might get the degree, or if you just want that credential, you might want to get the master's degree along the way. Maybe just you get the non-thesis master's just to have the master's degree, even if you're continuing on the PhD. So either of those are possible. It just depends on kind of what would work for your particular situation, you know, how important it is to have that intermediate degree, and whether you kind of want to write that additional thesis or not. But the one thing I would say is if you are thinking about a PhD, if you're thinking about a research career and when you're looking for an assistantship, you probably will be more successful finding one if you're looking for a PhD. And this isn't always true. There are some projects that are conducive to short-term projects. And so the faculty member may be happy with having master's students just because of the nature of the research. In most cases, they would prefer to have a PhD student because if it's a master's student and, as I said, it takes a couple of years, well, that first year you're taking classes and then you're finally learning how to do things. And by the time you really learn how to be productive, you're gone. Mm-hmm. Whereas a PhD, you have that staying learning curve, but then you're still there for a few years and being more productive. Mm-hmm. So in most cases, faculty members would prefer to have a PhD. And as I say, it's not always the case because there are some types of research where those short-term projects work very well and these master's students work. But there's probably more. And if you do decide to get a PhD and then for whatever reason it doesn't work, then you can switch the other way from what we talked about and get the master's and leave. So it's just something to think about, and you may try to gauge from the group. If that group has a lot of master's students, well, then maybe that's kind of common. But if the group is all PhD students, then they probably are looking for PhD students.
That's great. Continuing on with the thesis versus non-thesis option, the question is, do students who take the path of being a GTA during their master's typically complete the thesis or the non-thesis option?
It may depend on the discipline. So if it were a pure GTA and that's all they did, then it could be the non-thesis. I think a lot will do, it's a combined appointment. So they're a GTA, but also a GRA. And if they're also a GRE, then they would do the master's. I would say the majority of our on-campus students that are one of that assistantship are probably most likely doing the thesis option. Because if you're here, then you have that opportunity to be paid for doing the work. But it's not a, if you're getting paid as an assistantship, then obviously you're doing research, so you might as well do the thesis. If you are strictly only doing teaching, then you wouldn't necessarily be doing the research, so it could be non-thesis. But I'd say the most common is probably a joint appointment where they would do the thesis.
Thesis as well. Okay, great. One clarifying question in relation to the master's in engineering. The student is asking, would you only graduate to receive certificates and not the full master's, or how does that combination look for specifically the interdisciplinary option?
I mean, you do both if you have enough courses. So, I mean, if you just do certificates and you have enough for the degree, then you can basically apply to the degree and you get it. So I guess it just depends on if that degree is of value and you have enough courses between whatever certificates you take, then you can qualify for that will likely fit the Master of Engineering requirements, a combination of certificates, yeah.
Wonderful. There has been a question in relation back to financial assistance and cost. Is there any differentiation between in-state versus non-state, or in-state versus out-of-state, or resident versus non-resident in relation to cost?
For the tuition, it would be the same as it is for undergraduate. Of course, if you get the assistantship and then you get the tuition fellowship, then you don't pay that. So you're either not paying in-state or you're not paying out-of-state, but you're not paying it, so it doesn't matter. Now, for the online, there is no difference. So if you're working, whether it's in Alabama or Georgia or California, doesn't matter. The rate is the same for in-state and out-of-state for online courses.
Wonderful, thank you. Transitioning a little bit to timeline. So I know you've mentioned previously or throughout the session that if a student were wanting to consider graduate school, what does that rotation look like in terms of timeline? So could a student start in the spring semester in any of our programs, or is it currently only to the fall semester?
Students can start in spring. How common that is depends on the program. So most graduate programs are really quite flexible in terms of the particular course requirements. Some do have some core courses, and so there might be a sequencing issue, but I think in most cases you can. I think it's more common in some than the other. So I would talk to the particular program as to how, if that's at all an inconvenience to start. Because if you have a set of core courses that everyone takes, if you take them out of sequence, it might be a little bit harder. But as I said, that's generally not as common. I think only 2 or 3 programs have specific core, and they may not be as critical to sequencing as like undergraduate courses. But generally, you can start in the spring. It's just we do have a larger number that start in the fall, and even in the summer. So sometimes if you're planning to go in the fall and you're already done with what you were going to do, you have the summer off, you can start the research in the summer. And you might not take courses because there's usually fewer courses in the summer, but you can get started in your research over the summer. That's sometimes allowed too.
Okay, great. So this is in relation to graduate level coursework. Can a student currently at the undergraduate level start to take any graduate level coursework that would then potentially apply to a graduate program?
Yeah, so many programs, and we're working towards all programs, but not quite yet, have the accelerated bachelor's masters, which allows you to do that. And there are other ways you can do that. Honor students can do that, and I think there are other ways you can request it under certain conditions. So yes, you can get graduate credit. There's usually a limit of up to, the most you can use for both is 12 hours, but for a 30-hour degree, the most you can double count is 9 hours. But you need to check on the particular program as to which courses will count and how many they'll count. Some have limits. Maybe the graduate school says it could be 9, but they may say it's only 6 for that particular program. But yes, you can take graduate courses. So that would be when it's a 5,000 level course. Typically, there's a 6,000 level equivalent. So you're probably sitting in the same class that you were sitting in. You probably, if you're senior, you probably sat in these classes where there's graduate students and undergraduates sitting together, but some are registered for 5,000, others for 6,000. And then the students in the 6,000 level will have to do either extra work, maybe there's an extra project or extra paper, or maybe there's a different set of homeworks or different exams that are a little more rigorous and they're graded separately. So there's maybe a little bit of a difference in expectations. So there'll be something different, more work, more rigorous work that you'll need to accomplish. And then that 6,000 level course will count for the 5,000 level equivalent in terms of your degree requirements for the undergraduate degree. So yes, you can count, as I say, up to 9 hours for both degrees, but you need to check with the program to see on the specific course to make sure you take a course and that it will be allowed, but it is possible.
Wonderful. So as more questions kind of trickle in, I'm curious, Dr. Fergus, if you can share What are some expectations that you, along with our college, have for some of our applicants considering graduate school?
So as I said, there's kind of two levels. One is if you're looking for, are you acceptable to the program? That's mainly based on, do you have the right background, the GPA? GRE scores are becoming there's a variation in terms of whether they're required or optional. I personally think the GPA is a better measure than the GRE in terms of capabilities, but that you have the background and capabilities to be successful in the courses. So that's one part of it. And that's basically your academic record that is used for that. Then for the research side, and that's often the more difficult side, is are you going to be a good researcher? And part of that is the academic preparation. So you do need a certain level of preparation, but a lot of it is, attitude and work ethic and things like that, like any job, really, because it's more like you're being interviewed, or if you have the opportunity to interview, you're being interviewed for an assistantship. It's really a job. You're going to have to do research. You're going to have to work with people. Most of these research projects, there'll be a project and different students are working on different aspects of it. So it's really the same kinds of things that you would need to, this office is providing help for it, and how to communicate and work with people and solve problems. And, so that's sometimes harder to get from an application. So that's why we often invite students to come, both for them to see Auburn, but also to get to know them and to see if we think that they'll be able to be successful in the laboratory. So in your resume, showing experience obviously helps that you've at least done that before. You worked in a lab. That doesn't always say how well. And so, if you're really interested, you want to take the opportunity to talk to the faculty members so you can convince them that you're going to be a good worker in the lab and successful in accomplishing the research. So the academics is one thing, but then it's all the same things that you need to be successful in really any kind of job.
That's great. So this was great. Multiple students kind of asked very similar questions. So they have co-op experience at the undergraduate level. So in your experience or in your background, is the co-op opportunity beneficial for students who are considering graduate school kind of an added layer that maybe through their application process, but also do you see typically students that do the co-op at the undergraduate level pursue graduate school?
I don't have statistics, so I don't know how many, but I would say yes, a lot do. Obviously the research experience is more, it's easier to say I did research, now I want to go to graduate school. It's a direct connection. If you have the co-op experience and you want to explain why you go to graduate school, that you may have to explain that because it's a little bit of different, but it's still experience. It's still, as I say, a lot of it is that work, same kind of things as work, and you have that experience outside of the class. So it still will be beneficial. I think it's just not as a direct relation. It's very easy to say, I worked on this project and this made me want to go to graduate school because I want to do more research. So particularly if someone's looking for an assistantship for, say, a PhD, you want to convince them that, yes, you really want to do this, because really getting a PhD, it's not that you have to be that smart. You have to have a certain level of academic qualifications. But those that don't make it, it's usually not because they're not smart enough. It's because of the persistence because research is frustrating. By nature, you're doing something no one has done before, and so it's not going to work every time. And so being able to get through that is really the harder part, and that's where students usually fail, not so much that they can't understand the material. So they want to be convinced that, yes, this is something you want to do, and that you're going to stick with it for those 4 or 5 years if it's a PhD. Obviously for a master's, maybe it's not as, the shorter term may not be as critical, but still going to want to see the same kind of qualities, and it's still going to be failures. You have to really, that failure, you learn something doesn't work is what a failure is, and how to deal with that, how to go get through that. So it helps. It's just when you're explaining your career, to put that in context, is it may not be me. You did that and you said, I learned from this co-op, that's one thing I don't want to do, and so now I want to do this for some other reason. Or maybe something you did in that co-op said, boy, in this experience I saw these, this other part of the company that was working on these new projects, and I saw the people there were doing this research, and I wanted to do that. So it could actually come from your co-op experience. Mm-hmm. I guess the point is, the experience is good, and if you want to build on it, if you can, you'll need to demonstrate why you chose this particular career path, just like you would for any job. They want to see that you're going to be the right fit for this particular position.
Mm-hmm. Absolutely, thank you. Question kind of relatable, but just different. You mentioned a little bit earlier and throughout the presentation how the transition to remote work and all things COVID-19. Can you share with us, how has that transition looked for current graduate students who are working within the labs, working within research opportunities? What has that transition been like for current students and also faculty within research?
So the research efforts have continued. So even though classes are remote, throughout this whole time, research has continued. So what's happened is, where it's possible, people have done that research remotely, where sometimes it is possible, you're doing analysis, you're writing papers, those kinds of things you can do if you have a computer, it doesn't matter where. But there are some laboratory things that have to go on. So some of it's been readjusting a schedule. So maybe we were going to do this experiment, we'll put that off a little bit, but then we'll work on doing the analysis from a previous experiment or writing up this paper or whatever it might be. But where it is necessary to do experimental work, that's being done. And obviously precautions are being taken to make sure people are safe. So for example, in a laboratory, if it's crowded and people are working too close together, then there have to be shifts or some way of making sure there's fewer people in that lab, and with the PPE to keep them safe. So there's been a lot of precautions that have had to been taken to make sure when the laboratory work is needed that it's done safely. But it has continued, but sometimes with some adjustments, where let's do the stuff that we can do remotely for now, and we'll come back to the in-person stuff later.
Wonderful. There is a specific question in relation to one of the newest degree programs you mentioned with data science. You mentioned that there are more of a mathematics route, engineering route. Can you speak to that program a little bit more, and maybe some of the connection into future opportunities within that field?
I can't talk a lot about is computer science going to be here next week?
They will be, yes.
Okay,
yes.
Good.
Perfect segue.
so for the details on the program, I think that they would be able to answer that much more intelligently than I would. In terms of the value of the degree, I mean, this is everywhere now. How do you manage data? How do you use it? Every field, my own field, materials, are there ways we can use data to avoid, for example, if you're trying to use a new material for a new product, it can take years and years and years to make different compositions and test those and go back and forth. If you can computationally, you're using data and science to narrow it down to a few experiments, that saves you lots of time and money. But so there's many applications of analyzing data. So it's a growing field. That I can talk about. In terms of the details of the program, I can't do that intelligently, so come next week.
That's fantastic. Thank you for the plug for that. But that is a perfect transition. So just kind of wanted to wrap up our time together. I wish we could spend a whole other hour with you, Dr. Fergus. This was fantastic. And I just want to thank you for your time today, and also to the students for being here that have vested interest in pursuing graduate programs here at Auburn. And so we would love to keep all of you, and so finding ways to do so. But just kind of as we wrap up today, as you mentioned, Dr. Fergus, starting next week, students, we have offered the opportunity for our graduate program officers to join us in a similar fashion. So next week, starting on Monday, we do have the computer science and software program, as well as materials. Our program officers will be hosting a panel, a Q&A, to talk more specifically about their individualized programs, to also include opportunities that are for students in those programs. Tuesday, we'll have industrial and systems engineering for both the master's and PhD level. And then wrapping up midweek will be our civil and mechanical programs. So students, if you are interested in any of these specific programs listed here, that will be an opportunity that I would love to have you join us next week. You can register on Handshake just like you did for today's session, and we will set up this very similar structure for you to be able to ask specific questions. We wrap up the series next Thursday. We have invited 3 Auburn alum who all attended graduate school here as well, to share more about their specific experiences and also that connection to industry. So how they feel, why they pursued graduate school, how they feel like it best prepared them for their futures as engineers. And so we would love to have each of you continue to join us. I think this was really helpful today to learn more about why graduate school and the important entities associated with the graduate programs, but also as a way to still connect. And so that's what I would encourage you all students as well, is even after today and after next week, how can our office within Career Development and Corporate Relations continue to support you in considering graduate school? If you know for sure, I know if I were trained in engineering, Dr. Fergus has sold me of the benefits of graduate school and why I should go. So have our office, reach out to our office. We can assist you in developing your resume, your CV, your application material, and we can even go through that process more in depth individually. So with that, I know we have a few other questions that kind of popped up into the chat. I will follow up with you, Dr. Fergus, with those specific questions. And students, after today, I will be sharing this recording with you. I will also include the listing of the graduate program officers and their contact information as well. So if you want to reach out to a specific program to learn more. But again, I just thank you all for your time. Dr. Fergus, thank you so much again for spending your Friday lunchtime with us. And I hope you all have a wonderful rest of your Friday, and we look forward to seeing you next week on our session. So thank you again.
Thank you. And if anyone has questions, please feel free to contact me.
Wonderful. Thanks, Dr. Fergus.